Assalamu alaikum, my dear cadets. I welcome you all. As you know, it's a very critical moment to you all where the COVID-19 pandemic has scattered everywhere in our country and also all over the world. So be safe and unsound and stay your home. Don't go anywhere. However excellent you are, I am Muhammad Ashik Rahman, lecturer in chemistry at Borishal Cadet College. Today I am going to start my lesson on chapter 2 and the name of this chapter is organic chemistry, which is included to your chemistry second paper, and the topic which you will be taught today is the concept of spatial explanation of some organic compounds like fatty acid, amine, amide, phenols, and alcohols. It's the learning outcomes today. By the end of this lesson, cadets, you will be able to explain the acidity order of fatty acids, which is already taught in the previous lecture. And the next explain of the basicity of amines. And the next one is the explanation of acidity of phenol and alcohol. So first of all, we have to discuss the topics, the basicity order of amine, to explain the basicity order of amine. First of all, you have to understand the definition of base. Do you know, boys, what's the basicity of, what is the definition of base? A base is one which donates, which present, in which present lone pair electrons in any element in any compound, which can donate to another element or chemical species, like ammonia molecule. Here you see that the nitrogen element atom in ammonia molecule contains one lone pair of electrons, so it can easily donates to another chemical species. That's why ammonia is ammonia have the show the basic properties. So ammonia is a base. Now we have to explain the another compounds, like here this is the example of primary amine, and the chemical structure and the chemical name is also, it is the primary amine or 1-degree amine, and the chemical or UPAC name is methylamine, sorry, aminomethane, and the general name is methylamine. Here you can see that this compound contains only one alkyl group, that is methyl group. That's why it is called primary or 1-degree amine. Now, if we have to compare the basicity of amine between these two compounds, do you can you think that which compound have have shown the more basic properties between ammonia and methylamine? To explain this question, you have to follow that here methylamine contains a 1 contains an alkyl group which is methyl group, and we know that all methyl group connects as an electron releasing group. That's why here in methyl amine, the methyl this methyl group can donates have the ability to donate electron density to nitrogen atom. That's why, as a consequence, the electron density will be increased on the nitrogen atoms. That's why the methyl amine can be easily donates any chemical species than that of ammonia molecule. That's why we can say that here 1 degree primary amine, that means the methyl amine is more basic than ammonia molecule. So here ammonia is less basic and the methylamine will be more basic character. Now consider the next one. Here, first of all, follow the chemical structure of this compound, which is methylamine. Obviously, it is 1 degree or primary amine. Now we have to compare that the following compounds. Here you see that here 2-methyl group is present in this compound. That's why it is 2 degree or secondary amine, and the chemical name is dimethylamine. If we have to compare between these two compounds, then first of all we have to consider the presence of alkyl group. Here, first of all, we have to consider the methylamine. Here, you see that in methylamine, here only one methyl group or alkyl group is present here, which have the ability to donate electron density to the central element, that is nitrogen atom in methylamine. But in dimethylamine, here two alkyl group can have the ability to donate electron to the central nitrogen atom. So in dimethylamine, there is more electron density on nitrogen atom. That's why this compound, that means 2 degree amine, have the ability to donate electron to another chemical species is very faster than that of 1 degree or methylamine. That's why you can say that the methylamine is less basic compound and the dimethylamine is more basic compound. So secondary amine shows the maximum order of basicity than that of primary amine compound. Now we have to explain the next one. First of all, see the chemical structure of this compound here. You see that this is a dimethylamine because, and it is obviously a secondary amine because this compound contains two alkyl group here, and like a two methyl group is present here. Now we have to see, we'll have to see the another chemical structure here. You can see that this compound contains three methyl group, 1, 2, and the last one. So, and the chemical name is trimethylamine, and this is 3 degree amine. If we compare between these two compounds about basicity order, then obviously we have to conclude here 3 degree. Here 3 degree amine will be more basic than 2 degree amine because in 2 degree amine there is two alkyl group is present here, but in case of trimethylamine, that means 3 degree 3 degree amine or tertiary amine. This compound contain 3 alkyl group is present here. That's why this compound will be more basic in nature, but it is false. That means here 3 degree amine cannot have the ability to show more basic structure than that of secondary amine. Here one region is appeared for this region. Here the reason is that hysteric hindrance. Hysteric hindrance or hysteric effect is an effect by which a chemical species cannot placed to a fixed site. That means here you see that nitrogen atom have three alkyl group here, one, two, and three are alkyl group here. If any incoming group wants to be bonded to the nitrogen atom, in this case here place is not available to bonded with nitrogen atom. That's why the incoming group cannot be placed in this position due to steric hindrance. That's why tertiary amine is less basic than 2 degree amine. So here we can say that tertiary amine is less basic than 1 degree and 2 degree amine. This is due to actually the steric hindrance of this effect. So here tertiary, and here and the next one. Now we have to compare the basicity order of this following compound. So do you think, boys, which one is the more basic compounds in this case? Obviously here 2 degree amine, that means dimethylamine will be the more basic structure in this case, and the last one, that means the tertiary amine, will be the less basic structure in this case. That means the basicity order of the amine will be the following one: 2 degree is greater than 1 degree is greater than 3 degree, and the last one is ammonia molecule. Now we have to discuss the acidity in phenol. Phenol shows the acidic properties. Here is the structure of phenol. When phenol is dissolved in water or phenol is added with water, then phenol gives phenate ion and proton ion in aqueous solution and shows the acidic properties in phenol. But this region can be explained by the resonance effect in phenate ion. In phenate ion, resonance effect is appeared, which can be explained by this by the following structure. First of all, the structure of phenate ion. This is phenate ion. Here, in phenate ion, the electron density which is present on the oxygen atom, like this negative charge, move to the benzene ring by the resonance and creates the following resonance structure. And we you see that in resonance effect in phenaton there is four resonance structure is possible here, and here you see that the electron density increases at the position of 2, 4 and 6. That means in phenaton the electron density is increased at the ortho para position. That's why after releasing proton ion of phenol, the finite ion, the electron density, or the negative charge will be neutralized by resonance effect in finite ion. That's why photon can be easily released in this case. By this way, phenol shows the acidic properties by releasing the photon ion in aqueous solution. Now we have to explain that the acidity in alcohol. In case of alcohol, if alcohol is dissolved in water, then we have to get the following structure. That means there would be alkoxide and proton ion, but here in case of alkoxide ion, the negative charge on the oxygen atom cannot be neutralized in this case, because in alkoxide ion there is no resonance effect. That means there is no delocalization of electrons. That's why alkoxide ion will be unstable here. That's why the proton ion again join to the alkoxide ion and from alcohol compounds. So you can say that in alcohol have no acidic properties, whereas the phenol ion whereas the phenol have the ability to donate proton ion. So we can conclude that phenol phenol shows the acidic properties, but alcohol are a neutral compound due to the presence of alkoxide ion and its negative charge. So alcohol is a neutral compound. It is final, and this is the some findings of this lesson. Today's is the first one is trichloroacetic acid is more stronger than dichloroacetic acid, and the dichloroacetic acid is more stronger than monochloroacetic acid, and finally the monochloroacetic acid is more stronger than acetic acid, and acetic acid is a little stronger than formic acid. The homework for you, the first one, here is a creative question. Here you see that two compounds is present here, first one is the formic acid and second one is the acetic acid. By using this stem, you can have to you maybe solve the following questions. Okay, boys, no more today. Now I'd like to conclude here. So be safe and sound and stay your home. Thank you, and thank you all.